mic's working, which I always seem to do after I start it. All right, mic is working. All right, so let's rock and roll. So number 29, we need to find the distance and we need to find the section division of this line segment. So first thing you should do is you should plot A and B. A is at negative 1, 5, 1, 2, 3, 4, 5, and B is at 6, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. All right, so we mentioned earlier that distance formula is the Pythagorean theorem, right? It's just x's and y's subtracting each other. Put your headphones away, please. So what we're going to be doing is we're going to be measuring how long this is. Now, do we need a formula to measure how long this is? No, it's a horizontal line, so we can just count it. How long is this line? 1, 2, 3, 4, 5, 6, 7. So the distance is 7. Could I back that up with the formula? Yeah, I could. X's minus x's, well, that's 5 minus 5. Y is 6 minus negative 1. Well, 5 minus 5 is 0, so that's just 0 squared, which is nothing. And then we have 6 minus negative 1. Well, that's 7. Squared is 49. So we have minus 49 here. Rooted equals C. Oh, that's a plus. Sorry. Plus 49. And then we have root 49. And what's the root of 49? When we root 49, what's the square root of 49? 7. Just like I said it was, right? Yeah. So that's the formula that I did, right? But if you have just a segment like that, just count it, right? It's no big deal. It has no vertical component at all. So, of course, this is going to be 0. What? What if it's not? Then you need to use the Pythagorean theorem just like I did. Plug in your coordinates and find your number, okay? So it turned out that this guy's a 0, right? Because that's y minus y. Well, the y's are the same, right? They're both 5 above. So of course they're going to subtract to be 0. There's no vertical distance here, right? So that just goes away, and really all we get is the horizontal distance, which we can count. 7. So maybe if this was different, like this point was up here, Abby, right? If we were connecting from here to here, then this guy's y value would be 6, 7, 8, 9. That'd be a 9 there. So we do 9 minus 5, which is 4. 4 squared is 16. So we'd have a 16 here.
What does it mean by 2 sevens?
You put them all together. You what?
What does it mean by 2 sevens?
So this is separate. Remember, they want us to find the distance, which we did. It's 7, right? Now they want us to find the point that's 2/7 of the way from A to B. Now you could use section formula, right? Everybody remember this guy? P equals mx2 plus nx1 over m plus n. And then the same thing for the y's. Remember that? We could use this. We could. But there is a shortcut I want to show you. So first let's talk about this. 2/7 of the way. Well, that means we have A and we've got B, right? And we want 2/7 of the way. If I wanted to find something 2/7 of the way, how many segments should I divide up A and B into? 7, right? 1, 2, 3, 4, 5, 6, 7. I'll number those. And 2/7 of the way is right here. Yeah, from A to B. Okay. So over here we have 2, and over here we have 5, and that's our m and that's our n, and you could plug those in. Your x's and your y's are just your coordinates. Okay? So you can plug that in and figure it out. Make sure you do x2 first. x2 is 6. It's the value of b. And y2 is 5. Make sure you do the second one first. That's very important. Otherwise, what will end up happening is you'll find 2/7 of the way from B going to A, which is right here. You see what I'm saying? It's like you're starting at A, going 2/7 of the way. That's what we want. If you goof them, you'll find it this way. Now, if we're clever, we'll notice that we divide this by 7, right? We take 2 of them. This line segment's already divided into 7 pieces because it's 7 long. So where's 2/7 of the way? Well, it's right here between A and B. Yeah, right? There it is. If you have a straight horizontal line or a straight vertical line, you can just kind of see where it is, right? 2/7 of the way. Here's 7 pieces. 1, 2, 3, 4, 5, 6, 7. 2/7 is here. That's all. The formula is most useful when you don't have a vertical or horizontal line, right? you've got some kind of diagonal, and you can't just look at it and plot your point. But if you've got a flat line like this, by flat I mean horizontal, right, take the win. 2/7 of the way is right there. So what's that coordinate? It looks to me like it's 1, 1, 2, 3, 4, 5. And that's what you'd get if you plugged in these numbers. Check it out. If I plugged in 2 and 5 for m and n, this is what I would get. I'm going to do that down here at the bottom, okay? So 2 and 5 are m and n. That means 7 on the bottom, right? Comma, 2 and 5. Whoops, a plus sign there. 7 on the bottom. My x2, what's my x2 from the problem? Got a lot of different answers. My x number 2. X number 2 is 6. And my x number 1 is -1. Whoops. I got plus signs all over the place here. What am I doing? So I've got this plus this over 7. What's 2 times 6? 12. 5 times -1? 12 plus -5 is 7. So 7 over 7 is 1. Oh, I'm sorry, you guys can't see. So 1, comma, over here, what's my y number 2? What's y number 2? 5, so I plug that in. What's y number 1? Also 5, right? Do you see? And so I get 10 plus 25. So I get 35 over 7. What's 35 over 7? 5. 1, comma, 5. And oh, look, that's exactly where it is. So, could I do it mathematically? Yes, there's the formula, right? For this one, it's actually easier to eyeball. If this line were here, right, like Abby was asking earlier, if it was this line that we were trying to find 2/7 of the way, we couldn't just count squares, could we? That's what the formula is useful for. So if you'll notice, in order to memorize this formula, in order to know it for the exam, it's just the same thing for the x's and y's on both sides here. M, x2 plus n, x1. 2 comes first, over m plus n. And then the same thing for the y's. So you could do it with this kind of line, with the formula, or you could be clever with a flat line like this and just kind of eyeball it. Either way it works. Either way it works. What's up? That's cool. Hold on one second. I'm going to see if I've used this page already. Have we already done 27? We have. So, Dave, you can have this. Okay. Let's talk about, we just did a 28, I believe, so 29, right? Or was that 29? That was 29. Thank you. All right, so here is 30. This should look familiar. What is the length of AC? So first, where's AC? What's AC? No, like what is, where is it on my diagram? The bottom of the triangle, right? Okay, so here's AC. We want to find the length. Can we just count? Can we just count it? It's a diagonal. We cannot count it. So here's what you do. You can either take those two coordinates and plug them into distance formula. We've talked about that earlier. Or you could be clever. And you could draw this and make it a right triangle. Because now we've got Pythagorean theorem. Remember, Pythagorean theorem, same thing as distance formula, just a little bit easier to use. So this is 3 and this is 1. How do we find this length with Pythagorean theorem? Mm-hmm. And which letter is going to be this length right here? C, because it's the hypotenuse. Good job, Jade. So we have 3 squared plus 1 squared equals C squared. Remember, we want to know what C is. That's the length. So I do 3 squared, which is 9, and 1 squared, which is? And so I get 10 equals C squared, which means root 10 equals C. Ta-da! Could you have used distance formula and found the same thing? Absolutely. You could have plugged in those coordinates. But when you're given a graph like that, if you're clever, you can draw yourself a triangle and make it work. And not just any triangle, a right triangle, because that's the only way Pythagorean theorem works. Now we need to find the midpoint of AB. The midpoint. Remember, midpoint formula is this guy. the average of the x's, comma, the average of the y's. So let's find AB. AB's here. We can't just guess. We know the point's going to be somewhat like there. We can't just, count it. But there is a way to kind of guess about it, right? I bet it's something like comma negative 3.5, right? Up 3. So my guess is negative 3.5 up 3. That's my guess. But let's make sure. A's coordinates are negative 4, comma 2. And B's coordinates are negative 3, comma 1, 2, 3, 4. So negative 3, comma 4. So if we put those into midpoint formula, this down here, here's what we get. Our midpoint is going to be the average of the x's. What are my x's added together? If I add those together, negative 7, very good, over 2, right? Because we have to average them, right? What are my y's added together? Okay, well 6 over 2 is just 3, right? So negative 7 halves, comma 3. Well, that's B. And guess what? Negative 7 halves is the same thing as negative 3.5. So I was right by guessing. I'm trying to give you as much as I can give you, Jade.
That's okay.
All right, okay. So it says for 32, ABC is reflected across the x-axis. Which axis is my x-axis? The up and down or left and right? The left and right. So we're taking this triangle and we're flipping it across here. Well, I can, eyeball that. A prime is going to be here. C is going to be here. C prime. Remember, it has to be the same distance from the axis, right? 2 and 2, 3 and 3. And B is going to be 1, 2, 3, 4 over here, it looks like. So there's B prime, A prime, and C prime. There's my new triangle. And it says, what is the rule for reflection across the x-axis? Now, this is kind of a trick question. Because you might think x-axis, oh, we changed the x, right? But what kind of a flip is this? Vertical or horizontal? It's vertical. So what letter is going to change, the x or the y? The y is going to change. So x stays and y becomes negative. And if you check that, that's what happens. Our y value here is 2, right? It's up 2. And what happens down here? Now it's down 2. It was up 3, and now it's down 3. It was up 4, and now it's down 4. So the y value got negative, right? That's what happened. So what are the new coordinates? Well, you can write those out, I think, right? You can figure that out. Just take these guys and make their y value negative and plot it. Well, we already did. So there's that. Let's turn that page. We're on page 14, everybody. We're on number 35. Who can tell me what an isometric transformation means? An isometry. Iso means same, right? What does metric mean, you think? Whoops, metric. Shape or size? Size, shape,
Same size.
length.
So same size transformation.
Yeah, it's a same size transformation, right? We have a bunch of those. Who can list off a couple that are isometric? Meaning that they don't change their size after you transform them.
Reflection.
A reflection, right? Reflected doesn't change size, just changes position. The spin.
Translation.
Translation is the slide, right? Right? If I'm moving my pen, right? That's a translation. Did the pen change size? Absolutely not, unless I moved it this way.
What about a flip?
A flip, which is a reflection, right? So we already mentioned that. Flip is the same thing as reflection. What's the other one? I'll give you a hint.
Rotation.
Rotation, exactly. If I turn the pen, right, it doesn't change its size. What if I dilate the pen?
No.
Dilation makes it bigger, right? So not an isometric, right? Because it changes the size. So the ones that are isometric, translation, reflection, rotation. Ones that aren't, dilation, right? If pupils get bigger when you dilate them, that's not an isometry. Excuse me. All right, so it says, reflect this triangle over the y-axis. Which one's the y-axis, everybody? Is it the horizontal or the up and down? Ooh, we've got a debate here. X-axis versus y-axis. I want to know which one's the y-axis.
The one going up and down.
Up and down. Yeah, I figured, Jade. I figured. All right, so that's our y-axis. So if we're flipping it over the y-axis, we're flipping it this way, right?
No. Wait. Yeah.
Yes, we are. It's confusing because you think, why? Up and down, right? No. We're flipping it horizontally. So if we do that, that's step one, right? It says flip it over the y-axis. So that's step one. Let's do that. If I flip it, well, it should be the same distance from here as it is from here, right? So that's where A prime is going to be. Everybody follow me on that? It's 2 from the y-axis, so it's still going to be 2 from the y-axis when we flip it. And then we've got 4, 4, That's C prime. And B is also 2 away, so B prime is going to be 2 away on the other side. How do we feel about that first reflection? Decent? Okay, okay. And then step 2, it says translate it by vector 3 comma negative 1. And that's as confusing as they could have stated it, right? What does it mean to translate? In math, at least. What does it mean to translate something? What's another word for it? You know, like a reflection is another word, it's a flip, right? What does translate mean to do the object? It means to slide it, right? So we're going to slide this guy 3, negative 1. So 3 to the right, because that's the x, right? And then 1 down. So we take everything here, and I'll do this in another color. Do it in green. We take every point here, and we go 3 to the right, 1, 2, 3, and then 1 down. So now A prime is over here. Does everybody see why I did that? 3 to the right, 1 down? Okay, so 1, 2, 3 for all of these, and 1 down. That's C prime. And then 1, 2, 3, and 1 down. That's B prime. So there's step 2. Okay. Rotate 180 degrees about the origin. All right. So now we've got to draw our L's. Remember those? So if we're going to draw our L's, let me use a different color. Let's use this color right here. So we go from the origin and we make our L. Well, there's our L, right? Right here. So if I rotate 180 degrees, I've got an L that looks like, where's the best way to do this? Like this, right? No, not like this. Like this. There we go. Like that. There's my L, right? And if I rotate 180 degrees, well, 90 is going to make it like this. And then 180 is going to make it like this. L for loser, right? All right. So if I do that, I'm going from here to here, right? I go from here to here. And then I flip it one more time, and now I'm going to end up in L loser land, right? So here we are. So A prime is going to end up here. Now if I do the same for C, his L is like this. You follow? Right? You follow? There's his L. So right now I've got this L for C. And if I rotate that 90, I end up like this. And if I rotate 90 again, I end up like this. So he's going to end up 3 this way. 1, 2, 3. And then 1 to the right. See how he was going to the left earlier? Now he's going to the right. Just like A was going to the right and then down, now it's going to the left and up. So C prime is here. Everybody following that? C was here. And then when I rotated it once, that's 90. Rotate it again, that's 180. So C prime is there. Now let's do B. B is just a longer version of A, right? We just extend that L down. So instead of going up 2, it's going to go up 5. 1, 2, 3, 4, 5. And there's where B prime is going to be. And that's step 4. So that's the final product right here, guys. Right here is what you want. Everything? Everything. Okay? Because it looks like you only got the first step down. But if you want, it's right here. All right, let's look at 37 real quick. Let's just eyeball this to start out. It says which transformation. So what can we do to make this guy, the M and P, go up to M prime, N prime, P prime? Remember, going from here to here, not the other way around. What should I do to go from here to here?
You go over 6 and go down 4. Or
Go over 6 and down 4. I'm going from here, Kenny, to here.
okay, so then to get to M from M is up 6 and over 4.
Up 6. 1, 2, 3, 4, 5, 6. And over 4? 1, 2, 3, 4, maybe? Maybe the opposite. Up 4 over 6.
That's what I meant.
Gotcha. All right. So Kenny's saying we can go up 4 over 6, and that's true. And then it would match up. And P would match up, but N wouldn't, right? If we go up 6, 1, 2, or I'm sorry, up 4, 1, 2, 3, 4, and then over 6, 1, 2, 3, 4, 5, 6, we'd have N here, so N prime. M prime would be correct, and P prime would be correct if we did that, but we wouldn't have N prime, right? So we got to do something else. Got to do something else. So instead of doing these, and Kenny, you're sort of right. There's just a step you got to do first. We need to get that n up top like this guy is, right? So how can we get that n up top, you think? Not going to be a slide,
If you rotation
a rotation or a flip.
of 180 degrees.
If we rotated 180 degrees, the only problem, Kenny, is that m is going to stay on the inside, right? It's going to go from here to here to here, right? That's not going to get there. So a rotation won't make it happen. You got to imagine that p is going to be on the outside if we rotate this object.
Wait, flip and translate.
So we need to flip it, actually. So, Kenny, watch this, watch this. If I flip this, I get m prime here. Agreed?
Yeah.
And I get p prime here. And then n goes all the way up here. It's 5 here, so it's going to be 1, 2, 3, 4, 5 here. And now we're here. Now what do I do?
Move it over.
Slide it. See how that's a little bit better, right? It's going to get you there. There are millions of ways to do this, right? It's like if you're going to Casey's, there's one really easy way to go from here to there, right? Go down the road and take a right. But you could also go the other way, head left, go back and, right, there's tons of ways to get there. This is just the simplest way. So, Kenny, you were onto something, but I think this will be a little bit simpler. So, first thing is flip it. Whenever these guys aren't matching up, see how n and n are to one's top, one's bottom? You probably want to flip it or something, right? So we flip it first, and then we're going to slide it. So what kind of a flip did I do here? A vertical flip. So what happened? X and Y changed in what way? Did the X change? It's a vertical flip. Did the X change?
You got exchange?
Did the X change if we did a vertical flip?
No.
What letter changes if we do a vertical flip? The Y changes. So we have this. That's our flip, right? And then, after we did that, we slid it. Which direction did we slide it, Kenny?
Left.
Left. Did we slide it up at all?
No.
Nah, so we just left 1, 2, 3, 4, 5, 6. And my last question for you, Kenny. If we're sliding 6 to the left, is that going to be an X move or a Y move?
X.
An X move. So X minus 6 is what we're going to have. So we changed the Y to flip it. And then the last move was to also subtract 6, right? From the X. So there's your final move right there. All together, 6 to the left, and we flipped it. And really, you could have done it in any order. You could have moved it 6 over and then flipped it. Or you could have flipped it first and moved it 6. Either way, it works. Everybody cool with that? Morgan, you doing okay? Haven't heard much from you today. You doing all right? Okay. Yes, just down here. That's 37. All right, 38 we're going to skip because it was a dumb question before and it's a dumb question now. 39. What is the length of AB? We're only going to do one of these. I'll leave the other one for you. So AB is right here. So we know AB is 3x plus 8, but we need to know an actual number for AB, right? So AB matches up with DE on the other triangle because these triangles are the same. So here's AB, and here's DE right here, 5x. So 3x plus 8 must equal 5x because AB and DE are the same. And now we solve for x. I'm going to do something that's a terrible idea in real life, but a great idea in math. What am I going to do? Get your x's together. I'm going to subtract 3x from both sides. Gabe, you're on, or I'm sorry, not Gabe. Jade, you are on fire today. And then what do I do as my last step? What do I do to get x completely on its own? Divide, right? Because that 2 is bothering it, so we separate them. So 4 is x. We are not done, because now we need to go and plug that in and find out what AB actually is. Well, AB is 3x plus 8, right? So if I plug in 4, I get 3 times 4 plus 8, and that's going to be 20. Because 3 times 4 is 12, plus 8 is 20. I will leave angle EDF for you. That's the exact same idea, right? What does EDF match up with, Kenny?
Yeah. I guess what question I have?
No, I asked what question you have. Yeah.
Do we actually look at 38?
At 38, we're not going to do it. It was a dumb question before, and I wouldn't put it on the final.
Or you're not putting it on final?
I'm not. No. It's a terrible question. There's 2 possible answers on there, and I think they try to confuse you on purpose. There's no difference between lines and coplanar lines. They're just throwing a bunch of words out there to try and mess you up. I'm not a fan of those questions. Would you like to see that one, Gabe? Okay, I'm sorry. I grabbed the wrong paper. Ariana, you doing all right?
No, because you're going way too
Cough.
fast.
You what?
You're going way too fast.
Going way too fast.
Yeah.
Well, I will try to slow it down a bit. My worry is that we're not going to get through all the stuff that I want to get through, though.
Well, we
My-
could have done this.
I think we use the restroom.
Yes, you may.
Yes, it is.
40. It says, what is the component form of the vector that takes this guy to this guy? Well, all we need to know is what is the component of this vector. In other words, going from here to here, I went down 1, and I went over 1, 2, 3, 4, 5. So when I write that, I write minus 1, 5, with pointy brackets. Ariana, are you with me? Because I went down 1 over 5 to get from A to A prime.
Is 5 on the X?
Did I goof that? Oh, I totally did. Switch these. Thank you, Ms. Snyder. I went down 1. Down is a Y direction over 5. Thank you very much. I know it's not proper to open the president for the card, but I didn't have time to write it this morning. Things came up, so.
You are too
Well,
kind.
no, I am not kind enough, actually. I should give you more. Yes. I would not mark it wrong, but I would prefer that you do this because this is a vector, okay? It's not a coordinate. We're not talking about a dot. We're talking about an arrow that takes something to something else, okay? So at most, and again, I haven't talked to Ms. Fleming of what she would say with that, but typically I would mark off maybe a half. But, you know, who knows? Maybe we'll talk and she'll say, you know what, either way is fine. Yeah, since we're given the same final, it's, you know, we got to talk about stuff like that. But in general, I would not take off too much for that at all, if any. I'm going to do 41 and 42 pretty quick. So let's just talk about this. What's happening here? The x got changed, so what kind of a, what happened?
You went left on the x-axis.
Oh, think about that, Kenny. We negated the x. We didn't add or subtract anything. We put a negative in front of it. Remember when we put a negative in front of the y earlier? That was a vertical flip,
Oh,
right?
you're reflecting across the x-axis.
Oh, so it's a horizontal flip, right? That's what that means. So what axis am I flipping across? Imagine your coordinate plane, Kenny.
The x.
Try it again.
Oh, the y.
The y. Isn't it kind of a trick question? That's why I normally say, what kind of a flip is it? Well, x means horizontal, right? And it is a horizontal flip. If you want to think about the axis, though, it's actually going over the y-axis.
Oh, 'cause
You see what I'm saying?
the vertical flips over x and then horizontal.
Exactly, right? It's kind of weird. So I try not to make you memorize that. I like to make you memorize negative x, horizontal flip. But when they're asking the axis, you got to draw it, right? Make sure you're, you know, not goofing that. So it's actually over the y-axis because it's a horizontal flip. Now, Kenny, look at this next one. Are we putting a negative in front of anything or a number in front of anything? We're not, right? All we're doing is subtracting 4. So that's going to be some kind of a slide, right? A translation.
Yeah, you're translating left focus. No. Down.
Down. Why down, Kenny?
Because that's basically subtracting, isn't it?
Yeah, it's subtraction. And which one are we subtracting from? The x or the y? The y. And y goes up and down, right?
Yeah.
So it's not going to be left, although that's a very common answer for people to say, right? And it's not going to be right because that's x stuff, right? It's going to be down because it's minus 4 to the y. Cool. Again, if you need to see those, they're up here. Also, the video will be online. All the stuff from my single block class is up. We did it all yesterday, I believe. So if we don't get stuff here, you can check it out on there. Number 43, we have choices. Is it a reflection? Is it a rotation? Or is it a translation? Let's look at these figures right here. It's a reflection. And Kenny knows this because B was on the bottom and now B's on the top, right? Vertical flip. So a vertical flip is going to take X and Y, and it's going to do what? Change what letter?
The y.
The Y. Very good, Kenny. Now, bonus question, right? Because they're going to trick you on some of this stuff. What axis did we flip over?
The x.
Yeah! Kenny's got this. So this is a reflection over the x-axis.
Oh,
All right, so that answers both. That was 44. 43 is kind of this part, right? It's a reflection across the x-axis. You following me? Doing okay, Jade? Doing okay?
Yeah,
Yeah? You seem very happy. Did you make all those yourself?
these?
Yeah?
Yeah.
For actually that one, even if it is going across whatever side, do you want us to say it's
I think in this case they don't care about that, but it'll help you get this part, right? Which is 44,
okay,
right? That you know, oh, vertical flip, right?
yeah.
Yeah. So always think about it that way first, and then if they do ask about the axis, just be prepared, right? Just be prepared. All right, cool. So here's what we're gonna do. We're gonna jump through these proofs because I have videos online of all of these proofs already. They're from the Proof Palooza. If you want to check those out, they're on there. I'm even gonna try and make a separate video today just going over the proofs if you want to see them all in one video. All these proofs, okay? If you don't, they're all on the videos that we did before on proofs, right? For our proof quiz. They're the same ones. So check those out, okay? There are not going to be a whole lot of these written proofs on the final, if, any at all. But you need to know these concepts. I'm not going to make you write it all out necessarily, but I need you to be able to see that, oh, these triangles right here, since they're congruent, DB, right? This guy right here is shared with both sides, right? How do we prove that DB bisects these two angles? Well, these angles are going to match up because angle ADB is the same as angle BDC. BDC.
How do we put that in words though?
So angle ADB is congruent to angle CDB by CCP. Therefore, by definition, DB bisects ADC. So these two angles are congruent, and I know that because they match up. ADB, first, last, middle, right? Matches up with CDB, first, last, middle, by CCP. Right? That's what CCP is. The order of the letters matters, right? So we're able to say they're congruent because their letters match up by CCP, right? Then we say, therefore, this. Remember, we always end with what they ask us to prove.
That's all we got, right?
That's it. That's all. That's it. That's it for that one. I'm going to hit a couple of these real quick, like number 47 and 48. Let's talk about those. But in general, those proofs will be online. And they should be that simple, Kenny. All right, so prove that 2 and 8 are congruent. 2 is here, 8 is there. There is no alternate exterior angles theorem. We can't just be like, oh, yep, they're alternate exterior angles, therefore they're congruent. Can't do
So
it.
you could say, by vertical angles, you know that 2 and 4 are congruent.
2 is congruent to 4 by vertical angles theorem. Everyone remember that one? That's the scissor theorem. They're across from each other, right? So they're congruent. It's like the scissors that open up. Whenever I open up the scissors, the angle gets bigger on top and on bottom, right? So they're always the same angle. So these two are the same angle.
And then alternate interior angles makes 4 and 6 congruent.
So 4 and 6 are congruent by alternate interior angles theorem. Remember, alternate means opposite sides. Interior means inside. They're congruent. And then what's your last step?
And then by vertical angles theorem.
So 6 is congruent to 8 by vertical, right? Because they're across from each other. I shouldn't say last step. And then finally,
And then therefore, angles congruent.
by what property?
CCP.
Nope. These are not congruent triangles.
Okay,
Transitive. Yep. 2 is touching 4, 4 is touching 6, 6 is touching 8, therefore 2 is touching 8. So all that. There is a shorter way to do this if you want to follow along, okay? The shorter way is 2 and 4 by vertical, right? 4 and 8 by corresponding. You follow? And then 2 and 8 by transitive. Right, that cuts out the middleman, 2 to 8. So, are you seeing me, Kenny?
Yeah.
Right? We've proven that 2 and 4 are congruent. We proved that 4 and 8 are congruent. Now we need to prove these two, right? So, transitive. 2 is 4, 4 is 8, therefore 2 is 8.
So for that one, all we gotta do is just 2 and 8 are congruent for a vertical angle theorem.
Not 2 and 8. 2 and 4 vertical angle. 4 and 8 by corresponding. 2 and 8 by transitive. Or you can do it this way that Alex did it. he did it this way, Kenny. So what you have on your sheet says this: 2 and 4 by vertical. You follow me? Okay. 4 and 6 by alternate interior. 6 and 8 by vertical again, right?
Yeah.
And then lastly, that means 2 and 8 must be the same because transitive property.
So we gotta write this all out.
I would write those 4 things. Okay? Now, the next one, Kenny, 48, is much easier. Prove that 1 and 4 are supplementary. What do we know about angle 1 and 4? What do we notice?
They're,
They're on a line, so what do we call that? Yeah. Nope. I mean, this is a transversal, but 1 and 4. They're a linear pair. Remember that, Kenny? So angle 1 and angle 4 are supplementary by linear pair theorem. And before we had to do a lot more of writing because we had to prove all those little things because it was the beginning, right? But now that we've moved past and everybody kind of understands what's going on, we can kind of jump to the, the conclusion. 1 and 4 are supplementary by linear pair theorem because they're a linear pair, right? And then we're going to jump forward a bunch through these proofs. Again, if you want to see them, they're online. And I will post, I think, fingers crossed. I don't have a lot of time after school today, but I'm going to try and post a video with all of these proofs written out so they're all in one place. All right, here we go. So now what we're going to do, there's some more proof for 50 and 51 if you want to try your, try it again. There's some more angles to practice on 1 and 7. Right, 3 and 4. Yes, sir.
For 49, would I still do the same thing as this because it's basically the same column, just different letters.
Yeah.
So I can just write that same as
Pretty much, yeah. This isn't for a grade, but Kenny, if you wanted to try, it'd be very similar idea. Yeah, we want to prove B is a midpoint, so we need to prove that AB and BC are the same. How do we know they're the same? AB, BC, CCP.
So I can just write
Very similar, yes. If you want to see the actual proof, it'll be online today, or it'll be on one of our old videos, okay? All right, so now we're going to skip a bunch of these. I want to look at 54 real quick. How can we prove that these triangles are congruent? 54 on page 25. Gabe, this is your thing. No, remember, we can't prove triangles are congruent by CCP. It's only if we already know they're congruent. We can use CCP. Cheeks theory, exactly. So we know that we have a shared side here, right? So we have sides congruent, and angles congruent. And what does that spell? Exactly. And so we know that this is going to be Cheeks theorem, right? Because these are right angles. So by HL, we know they're congruent. Whenever you see ASS or SSA, you know you need to be looking for Cheeks theory. Thank you very much. That's the one thing we'll remember from this class. Let's turn the page and look at 56.
If you ever teach some other class next year, you can remember that.
This is true. So for 56, what missing information do we need to add to get this solved? We need to prove these two triangles are congruent. What missing information should we add here? The angles in the middle are congruent. How do you know they're congruent, Abby? Vertical angle theorem. And so now we've got angles matching, we've got angles matching, and we've got sides matching. So AAS. Nope, not cheeks. It's AAS, not ASS. So this is going to be AAS. Remember, in Cheeks theorem only works for 90-degree triangles, and we don't know that these are 90. So that's AAS for 56. Let's move ahead. We're skipping a bunch. This is just more practice, right? It looks like we did before. This is more practice with section formula and midpoint and distance, right? So practice those if you need more practice with that. They will be on the final. Page 29. Same thing we did before, just more practice on it, okay? Let's look at page 30, everybody. Real quick. Page 30. Page 30. It's number 67. I'll give you some time to catch up. Page 30. You got it? Good. Getting there? All right.
I'm following along, so we can
That's
put it
fair.
on my own later.
That's fair. That's fair. That's why we have the video. All right. So give me an example of a transversal here. Which line is a transversal? T is a transversal because it cuts two parallel lines, right? Or two other lines. Don't worry about that right now. It would just be a line that cuts two other lines. That's why this guy's the transversal. Doesn't have to be parallel. Doesn't have to be. That's why I corrected myself. It's any line that cuts two other lines. When these guys are parallel, magic happens, right? Then we can do all the other stuff. Corresponding angles. Give me an example of a pair of corresponding angles, somebody. 1 and 5 are corresponding. That's in blue. 1 and 5. Top left, they correspond. Top right, they correspond. 3 and 7 are corresponding because they're bottom right. Okay? That's the one everybody forgets, so make sure you know that one.
Transversal was the T, right?
The T, right? It's a line that cuts two other lines. Give me an example of same side interior. Try to use numbers we haven't used yet. 3 and 8 are not same side interior. Oh, no, it's 3 and 8 are. I thought you said 2 and 8. 3 and 8. I even said 3 and 8 out loud. 3 and 8 are same side interior. Because they're the same side and they're in the interior. Oh, boy.
Could just look behind me, but
Who
who does that?
does that? Give me an example of alternate interior.
2 and 8.
2 and 8. We had to double up, didn't we? So 2 and 8 are alternate interior angles. Give me an example of alternate exterior angles. We'll do that in orange.
4 and 6.
4 and 6. Very good. I'm going to move on in just a second. 5, 4, 3, 2, and 1. Again, if you need to see it, it's right here, and it's on the video, so you're more than welcome to watch it. Guys, this is more practice with the one we did earlier, right? We have to find which ones match up,
4.
set them equal, and then solve, right? So like CB and VU match up. So I set them equal, and I solve for x. 6x plus 2 equals 5x plus 7. Solve for x, right? Plug it back in. Okay, nice. I like hearing that. Let's take a look at number 72 on page 32. This guy right here. We've got our logic puzzle. This, I think, is Miss Snyder's favorite thing.
Yes.
All right, so we need to find these angles. Let's talk about this orange angle right here. That's angle ABC. So how can we find out what this angle is? There are a lot of ways to do it.
Oh, because
That's one way to do it. We figure out what this guy is
you
first,
know
right?
that angle C is supplementary, so it'll equal 180 minus 105, and then angle C. Yeah.
I see what you're saying. So Alex is saying we find this guy first, we can get this guy for free. That's true. There's a more clever way. What do we know about this angle and these two angles? What must be true?
The outside part.
The exterior angle equals this guy plus this guy. Remember, these two guys add up to this guy. These are remote interior angles. They add up to this guy.
35.
These two angles add up to this guy. They have to.
Yeah, so
Remember that?
35.
The remote interior, far away, right? So 35 plus whatever this is 105. So this must be 70. Everybody follow me there? Are there other ways to get that answer? Yes. You got to do a little bit more work first, right? You can find out that this guy right here is going to be 75 and then do math, right? Let's talk about the blue angle right here. So what angle is this going to be? This angle, CBD, which is
I would probably do
110, right? That's fair. That's fair if you do it the other way. 110, because this should be linear pair theorem, like Gabe said. They add up to 180. Nice job, Gabe. What about the green one, angle Bay, which we're all about Bay, right? What's that going to be? It's also going to be linear pair.
80 minus 35.
Well, 5 more to get to 40. So 145 to get to 180. You follow me? Okay, cool. Are there other ways to do it? Yes. And the big thing that you might notice is that if you know this angle right here is 75, you can get this one for free, which then gets you this one for free, which then gets you this one for free, right? So there are lots of ways to do it. Questions about 72? Okay, moving on. 73. We're going to do a lightning round. Here we go. Real triangle or not?
Yeah, no.
No. Why, Angel?
5 and 6 aren't greater than 11.
They have, the two sides have to be bigger than the third side, right? 5 and 6 equal 11, but they're not bigger. And that's what they have to be. Gabe, are you with us? Still looking?
Yeah, I know this one.
Okay, cool. I just want to make sure I don't go faster than you can flip your pages. The next one, yes or no? 65 plus 5 is 70. 70 plus 110 is 180, so yes. Interior angles have to equal 180. Here we go, a Miss Snyder favorite. All right, so this right here, what's this angle going to be? 5 to get to 100,
Can't do it in my head.
5 to get to 100, and then how many more to get to 180? 5 to get to 100, and then how many to get to 180? 80 more, right, to get to 180?
Can't do it.
It's okay. 85 is what it's going to be. Well, if that's 85, and that's 45, and this one has to be what? 40. Do those all add up to 180? We've got 85 plus 85. Nah, it's only 170, so no. Doesn't make sense, right? Not possible.
Oh, yes.
Next one. Remember, if it's the same side, it's the same angle. So this side goes with 35, and this side goes with 35, so this side should be 35, right? That angle should be 35. Is that a real triangle?
No.
Nah.
Why?
But all the sides are equal.
But the angles are not. Not possible. Contradiction. Because, yeah, you could have a triangle with all the sides equal, right? That happens all the time. But could you have a triangle with all the sides equal and all of them be 35? Because they have to be 180, right? They have to be, these have to be 180, all added up.
So if you add those up, it would-
They wouldn't be 180, right?
That's what I would do.
Right, it's not weird that the sides are all the same. That's fine. That happens all the time, right? The issue is that the angles can't be real. It's not possible. Let's take a look at 74. What are all these angles going to add up to? Remember, it's n minus 2 times 180. How many sides are there? So 5 minus 2 times 180. 3 times 180. Well, that's going to be 360 plus 180. That's 540. So all of the sides are going to add up to 540. Cool? So 90 plus 90 plus 2x plus 2x plus x should equal 540. You guys follow me on that logic? All these angles should add up to 540. If we subtract those, we get 2x plus x equals 360. How many x's do I have? Try again.
4 or 5.
5 x's. So 5x equals 360. And I divide by 5 for my last step. So x is going to be 360 divided by 5, which I believe is 72. Did I just make that up? 35, 10. No, I got it right. 72. I actually had that one memorized.
That's kind of weird.
I don't know. 72 is just a weird angle measure, and that just sticks out in my head. So x is 72. So if x is 72, how big is A? 72 degrees. And how big is B? Well, it's 2 times that, right? So 144. Which means E has to also be 144. Ta-da! I got you, Gabe. I got you.
Sweet. Well, that's something like sides minus 2 times 180.
Yeah, it's a formula for the interior angles.
Okay, I was just trying to make sure.
So if I gave you an 8-sided figure, it'd be 8 minus 2,
Minus 2 times 180.
which is 6. 6 times 180, right? Yeah, that's for interior angles of any polygon, as long as it's convex, which you don't need to worry about. We're not going to give you concave stuff. We talked about how I'm not a big fan of that distinction. All right, so moving on, 75. Let's do this quickly. Median. Here's your example. Vertex to midpoint.
I still don't know these.
Remember there's a Quizlet? I would study them. Vertex to midpoint. And the intersection of all of them is the medicenter. I would draw the diagram to help you out. An orthogonal. An orthogonal is vertex to 90. And they intersect at the, you guessed it, the orthocenter. Is this a bisector?
Yeah.
It is not. I did not say it had to be, right? It's just vertex to 90. There's a special name for something that's a perpendicular and a bisector. We call it a perpendicular bisector. Orthogonals are different, okay? Orthogonal is just a 90-degree line, okay? From the vertex. So start at the vertex, drop a 90. It's the height of the triangle, remember? You'll have to study those. It's okay. Mid-segment. Here's an example of a mid-segment. Midpoint to midpoint. That's a mid-segment. They have no center, right? If we were to do all of them, we'd get this. There is no segment for the mid segments, right? They just make the Triforce. Zelda. Bum, 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 bum. There's those. Let's talk about the perpendicular bisectors. What does it mean to be a perpendicular bisector, everybody? It bisects in the middle, right? 'Cause that's what bisects means, and it hits it at 90. So a perpendicular bisector of this triangle, well, there's a bisection, right?
That's the one that makes this.
And then 90, and that's the circumcenter.
That's the one I actually really know.
90 degrees from the
Yep, 90 degree from midpoint. So midpoint to 90. And then last is angle bisector. Well, what's an angle bisector, everybody?
Bisects an angle.
Bisects an angle. So here's our triangle. Here's an angle bisector. Right? And where do they all intersect? The in center.
I was gonna say in the center, but.
Yeah, yep. That's the one I get a lot when I notice kids haven't been paying attention in class and they just looked over the review sheet real quick. They write in center or in the center. And I think, well, which center? And then I realized, that's what they were thinking.
Hey, it works. It's fine.
All right, so I'm gonna pass this around if you guys want to take a look at it. I know it's taken a while. I can leave it up for 5 more seconds,
I was gonna do it.
but then we gotta jump. Then we gotta jump. Remember, it's on the Quizlet. All the information I put down here is on the Quizlet. So it'd be good to study that. All right. Gabe, I know you're not the fastest writer. You got them all? Dang. All today. It's the most wonderful time of the year. All right. All right, so 76. We're going to draw the same triangle 3 times. I know this is kind of confusing. We're going to draw the same triangle 3 times using these vertices. 0, 0, 6, 0, 1, 2, 3, 4, 5, 6. This copier is booty. 1, 2, 3, 4, 5, 6, 7, 8. The same triangle 3 times. So there's 1. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. That's a terrible triangle. Alfredo, if you're out there watching, I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8. 0, 0. 1, 2, 3, 4, 5, 6. Luckily, 6 appears to be the one line that really showed up. That vertical. All right, so we have the same triangle 3 times. We want to find the centroid or the medicenter. I'm going to focus on medicenter. How do we find a medicenter? It's the intersection of the what? We just covered it. Which ones form the medicenter?
The median.
Medians, right? That's why it's called a medicenter. Or at least that's why I call it a medicenter.
I was basically.
It's okay. And medians are from the midpoint to the vertex, right? So here's a midpoint. Here's a vertex. Here's a midpoint. 1, 2, 3, 4, right? Here's the vertex. Where do they intersect? It appears right there. Now, if I drew straight lines, you'd be able to find where that coordinate is. But it appears to be 1, 3. I'll go with appears to be. I know these graphs are, well, as I said earlier, they're booty. And Miss Snyder, I can tell, is already has her nose up against the table trying to see these lines. She's my most determined student. All right, so she just wants to pass. She's want to get out of here, No more high school. Orthocenter is the intersection of the orthogonals. And an orthogonal is a 90 degree, right? Well, from the vertex to a 90 is here. And from a vertex to a 90 is here. So the orthocenter is going to be there. Remember, 90-degree triangles always have a orthocenter at this point. So 0, 0. This is true for all right triangles, because orthocenters are 90 degrees. Yes, I could. I could scroll up just a little bit for you. Is that better, Gabe?
Yeah.
Okay. So there's our orthocenter.
The orthocenter goes from, where does it go?
It goes to vertice to 90 degrees. And if I start at vertice and go down 90, where do I end up? At the origin for this one, right? It's going to be always on that corner. Ladies and gentlemen, the vertice that's on the corner of the 90 is always going to be the orthocenter for a 90-degree triangle. Always is. Always. Just how it is. We had a question about that on our last quiz. On a right angled triangle, where is the orthocenter? It's going to be right there, Chief. Haha. Circumcenter. Well, how do we find the circumcenter on a triangle? Well, we need to find where the perpendicular bisectors intersect. So first find the midpoints. Here's a midpoint. 1, 2, 3, 4. Here's the other midpoint. And then we draw a 90-degree line. Well, that's this. And that's this. And you'll notice on a right triangle, they intersect in the hypotenuse, don't they? Well, if this is a midpoint, that's 3 and that's 3. And that's 4 and that's 4. So this coordinate right here, 3, 4. 3, 4. 3 to the right and 4 up, yeah? 3 to the right and 4 up. How you doing, Abby? Yeah. All right. Is that a new backpack, or am I just noticing this now? I think I commented on this earlier. Oh, yeah, when you took that early winter vacation and left us behind. I remember those days. Dark times. And then you came back with the hair, or maybe it was right before that you got your hair cut. You're just a new person, Abby. I just don't even know you anymore. Thanks, Kenny. All right. Turn the page. What kind of figure is this? It's a kite. And what do we know about the diagonals of a kite? They hit it in 90. They're perpendicular. That is key, ladies and gentlemen. Jade, I want to make sure you get this one because this is going to be on the final, guaranteed. That's a 90 right there. So it says if EBC is 48, EBC is 48, they want to know what's AED. Well, AED is just this angle. What's that angle going to be, Gabe? It's going to be 90, right? That's a silly question. We didn't even need to know about EBC. So AED is 90. Just for a bonus question, what angle is this going to be? If that's 90, that's 48.
That's good.
Nope, close, Kenny. 32. It's not going to be the same, right? They have to add up to 180. 90 plus 48 plus 32 is 180. And that means this one, that was my next question, is 32.
32.
And then Kenny, using that same logic, what's this angle then? 48. Nice. 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 All right, we're almost done. We're almost done. Is this a parallelogram? Well, we need to know if the sides are parallel, right? So we need to check to see if this slope is the same for AB and DC. So the slope of AB, well, that's the y's over the x's, right? So what's 8 minus 5? 3. What's 3 minus 2? 1. So the slope of AB is 3 over 1. Let's find the slope of CD, right? We want to make sure these two match. Well, the slope of CD, what's 8 minus 5? And what's 8 minus 7? Ah, they match. So these must be parallel. Now, how many sets of opposite sides do we need to be parallel for a parallelogram? We need 2. So we got to check the other ones too, right? You got to check those. Why are we finding the slope? Because the slope has the same thing as the angle. And that's how we're going to make sure they're parallel. So now let's check these. We need to find the slope of BC. Well, the slope of BC is going to be y minus y. What's 8 minus 8? 0. What's 8 minus 3? 5. So 0 over 5 is 0. Which makes sense. Slope of 0 means flat line, right? Horizontal. Now let's see if this bottom one matches. The slope of AD, MAD, mad. 5 minus 5 is? Looking promising. 7 minus 2 is? Oh, yeah. Are these parallel? Yeah, boy. Yes. Yeah, I mean, everything with 4 sides is quadrilateral. That's what you said, Alex, right? Yep. Yeah, there's not a really good proof for proof this is a quadrilateral. Looks like it has 4 sides, question mark. So we check the slope to see if they're parallel. How do you think we're going to prove this is a trapezoid then?
Because there's only one side parallel.
We only need one side parallel. So we got to check the slope to see if they're parallel, right? Let's find the slope. Now they give us a graph here, right? We can eyeball this. What's the slope between I and J? Well, it's down 1 and over 1, 2, 3, 4. So that's slope of IH, I should say. IH is down 1 over 4 to left, which is just a quarter. Does everybody follow me here? Left 4, down 1. That's the slope. Now let's find the slope between I and G. Do you think they're going to have the same slope? Do you think they're going to have the same slope? No way they're parallel, right? But let's do it anyway. I said I and G. It's J and G. J and G. Because those are the opposite sides. So we go left 2 and down 1, 2, 3, 4, 5. Kenny, are those two the same slope?
Yeah.
1/4 and 2/5?
Oh, I thought you were asking if they were like the same things there.
Nah. I mean, look at them, right? Is that the same angle? No way. These are not parallel. But that's okay, because trapezoids only need one side, right? So let's check the other side. Let's check IJ this time for real. So IJ is this one. Let's do that in blue. The slope here is 1 to the right and down 2. So it's down 2 over 1, right? The 2, and the negative 2 is the y. I totally just goofed these, but fair enough. These are not the same. All right, so this one, we go down 2 over 1. Miss Snyder didn't catch me on that one. You know what? That's one less Kit Kat. Spoilers. Negative 2 over 1 is our slope. What's our slope between H and G? I want you guys to try and find that on your own. What's the slope between H and G? It's down how much and over how many?
Down 6 over 3.
Down 6 over 3. Now, they don't look the same, but watch what happens when we simplify, right? What's negative 6 divided by 3, Kenny?
Negative 3.
Negative,
I mean 2.
negative 2. Is that the same as this?
Yeah.
Oh, yeah. So is this a trapezoid? Oh, yeah. Remember, trapezoids only have one pair of parallels. So it didn't matter that these guys weren't, in case you're wondering for those of you watching at home. Right? No, I did this top one, right? We had these two that we were comparing. But these two were the same. That's what matters. One set of parallel sides. So these two are kind of similar problems, right? Check the slope. Check the slope. Number 80. Find the area, find the perimeter. You know them, you love them.
Oh, that's a stretch.
Let's cut it up. So maybe like this. How about this? There are lots of ways to do it. There's probably an easier way, but I'll keep it like this. I want to give you guys a chance to do a rectangle and do some triangles. So that's how I cut it up, right? What's the area of a rectangle, Kenny? What's the formula? You with me, Kenny?
Huh?
Area of a rectangle.
Where's rectangle? Isn't it, length times
Yep. Length times height. Abby Piggott, what's the area of a triangle? It's the same thing except, yeah, right? It's just half of that, right? Yeah, because triangles are just half of rectangles. See, if I drew this, Kenny, I'd have a rectangle, wouldn't I?
Yeah.
And that triangle's just half of that rectangle. So that's the idea. The last thing we need is Pythag. Everybody, what is Pythagorean theorem? Good job, everybody. Thank you, Jade. She's there when no one else is ready to answer. All right, so let's find the area first. So let's do 81 first. I think area is easiest, right? So what's the area of this rectangle right here? It's 4 by 4, so it's actually a square. It's 16, right? Because length times height is 16. What about the area of this big triangle? It's 4 by 6. What's 4 times 6? And what's half of that? 12, because it's a triangle, right? We have to cut it in half. Let's do the next biggest triangle. We've got 3 by 2. What's 3 by 2? 6. And then we divide by 2 because it's a triangle, and we get? Try again. 6 divided by 2 is? 3. Got you twice now, Kenny.
I thought you said 3 divided by 6.
It's all right, it's all right. And then we've got 1 and 2 for that little triangle, right? So what's 1 by 2?
2.
Cut it in half. Juan. So if we add those all up for the area, we get 4 plus 12 is 16. 16 plus 16 is 32. Area is not so bad, right? Area is not so bad. The problem is perimeter. Sorry, Gabe. Perimeter, we're going to need to know all the lengths of the outside. Well, we've already got a head start. We know the bottom is 8, right? And we know the right side is 6. So that bottom right there is 8. Right side is 6. We need to find these lengths, here and here. How do we find this length, everyone?
You do 4 times 4.
Nope. What's the formula?
Oh, C squared, A squared plus B squared.
Pythagorean theorem is what we need.
Yes.
So it's our bottom squared, 4 squared, plus 6 squared equals c squared. Everybody follow me? 4 squared plus 6 squared is c squared. What's 4 squared?
16.
And what's 6 squared?
36.
Nice, not bad, guys. If we add those together, 16 plus 36, we get 52. If we root it, we get what? Root 52. So this is root 52. What about this right here? We've got 2 by 3, so it's 2 squared plus 3 squared. What's 2 squared? 3 squared is? Nope, 3 squared. 9. 9 plus 4 is?
12. Wait, no. 13.
13. So this is root 13. You follow me, Kenny?
That's 2 by 6.
Root 13. And that little guy right here, it's 2 by 1. So 2 squared is?
2. I mean 4.
And 1 squared is?
1.
So it's root 5, right? Because 4 plus 1 is 5. Now we add them all up. 8 plus 6 plus root 13 plus root 5 plus root 52. That's fine. I'll take that as an answer. I will take that as an answer. Let's split up root 52, though. I can split 52 up into 2 and 26. 2's done. 26, I can split it into 2 and 13. So what really is this? It's really 2 times 2 times 13. And what happens in jail? You got to find somebody that looks like you, right? You stab them in the back, and you sneak out in their body bag, right? So 1 snuck out. Does the 13 have anybody to stab? Nah, so he's stuck in jail. So it's 2 root 13. So check it out. I've already got a root 13 up here. If root 52 is just 2 root 13s, how many root 13s do I have in total? 3. So let's rewrite that. 8 plus 6 plus 3 root 13 plus root 5. Both of those will be acceptable. Let me zoom out, Gabe. I'm sorry. So we did the jail thing, right? And the 2 got out. And then we realized, I'm going to give you this page, Gabe, because I don't think I need it. Here you go. Yeah, that was the last little segment that we found. 5. 82! Complete the square. Or I'm sorry, rectangle. What do we know about rectangles? They have what? They have,
4 sides,
they do
90 degree angle.
90 degrees. So wherever C is, it needs to make a 90. It needs to have the same angle as this guy. Well, if we want the same angle, we want the same slope. What's the slope between A and B? Looks like down 3, left 4, right? So let's do the same slope over here. 4, 3. That's where C is going to be. And there we are. I've got the last 3 problems on the video for my first hour. If you want to check those out, do that. If you want some extra help sitting at school today, we can talk about those last couple of problems.